More about mean and standard deviation and how they're affected if a particular data point is added or removed from a data set. So for this right here, it says it gives you two dot plots, two distributions. The player distribution is the top dot plot, and the team distribution is the bottom dot plot. So obviously there's way more professional basketball players than there are teams. So that's why, yeah, your top dot plot has about 12 times as many dots as the bottom one. It says which distribution, the player or the team, has a larger standard deviation and why? Which one? The player or the team distribution? Player. And why do you think the player distribution has a larger standard deviation? Yeah, there's more variability. The data is more spread out. Or earlier today, my student said the data is further from the mean. Perfect. Remember, definition of standard deviation is the typical distance from the mean. So letter B is kind of a recap from Monday. It says the distribution of shooting percentage for teams is 1.5%. Interpret this value. Okay, so remember, standard deviation is a typical distance from the mean. So typically, a team's shooting percentage is about 1.5% from the average. And another word for average is mean, so you could put that there too, either one. And they're talking about the average for the whole league, okay? So they told us that the team shooting percentage is about 1.5%, okay? It says now estimate the standard deviation for the shooting percentage for players. It gives you a hint. Step one, find the mean. So I'm going to find the mean of this distribution. It's symmetrical, so the mean would be in the center. So I'm going to say the mean is about 45. Do you agree? Hopefully. So step one, find the mean. Sure, I estimate the mean to be about 45. Now, in order to estimate the standard deviation, you want to look for an interval that contains about 2/3 of the data around the mean. Okay, I'm going to look for an interval that contains about 2/3 of the data around the mean. Well, let me try if I go 10 away. If I go 10 out from the mean, 10 away from 45 in the lower direction would be 35, and in the upper direction would be 55. That contains, 2/3 is about 66, 67%. That contains more like 90 or 95% of the data. That's too much, so that's too far. So I need to go closer together. So rather than 10 away, what do you think I should try? Yeah, let's try 5. So if I go 5 below, that's 40. To 5 above, that's 50. Does that interval right there give us about 2/3 of the data? I'd say so. So therefore, the standard deviation is about 5 because that's how far out you're going from the mean. Okay, so what happens to the mean and standard deviation when one data point is added to a data set? Well, that new data point's position relative to the mean will kind of tell us what will happen to the mean. For example, if we add a data point above the mean, what will happen to the mean? Let's think about it, you guys. Let's say your grade in this class is an 80%. On next week's test, you get a 90%. What do you think is going to happen to your average in the class? It's going to go up. So if you add a data point above the mean should increase. Well, what happens if you add a data point below the mean? Again, you're grading this class in 80%. Next week's test doesn't go as well. You get a 60. What do you think is going to happen to your average in the class? It's going to go down. It's going to decrease. Not so bad. Now, let's talk about what would happen to the standard deviation. Remember, the standard deviation is dependent upon the new data point's proximity to the mean. If we add a data point close to the mean, or in other words, less than one standard deviation away, the data will do what? Think about it, you guys. If I add a data point close to the mean, my average distance from the mean is now smaller. So the standard deviation will decrease. If I add a data point far from the mean, so your data goes from looking like this, now you add a data point far from the mean, it looks like this, your data more spread out, so your standard deviation is going to go up. You're going to have multiple choice questions like this on your test, so you might want to highlight these. They're kind of general rules, but it's really good. You guys, we're going to practice these a lot in the next few days. It's really good to try and understand them. Don't try to memorize, okay? Try to understand. So let's practice it. It says, suppose we added one additional player who had a shooting percentage of 35%. So remember, you guys, on the previous page, this is the player shooting distribution. So the mean was about 45, and the standard deviation was about 5. So we add one additional player at 35%. How will this affect your mean? You added a point below the mean, so what's going to happen to the mean? It's going to decrease. Why? You added a data point that's less than the mean. Now, what about the standard deviation? You guys, remember, standard deviation is your typical distance from the mean. We said on the previous page that our standard deviation is 5. So a typical distance from the mean is 5. How far is 35 from the mean? 10. So it's higher than a typical distance from the mean. So what's going to happen to your standard deviation? It's going to go up because you could say because we added a data point far from the mean, we added a data point that's farther than 5 from the mean. Remember, X bar is the mean, so that's why you see me writing that symbol. Okay, take a minute and try the next one on your own. This time we add a point at 47. Our mean, 47% is higher than the mean, right? so it's going to slightly increase. If you just wrote increase, that's fine. The math teacher in me is going to write slightly increase. Standard deviation, you added a data point that's pretty close to the mean. It's only 2 away. So what's going to happen in the standard deviation? It's going to go which direction? Decrease. Good.
So it always has to decrease? Or it always has to do like something?
You know, the only way it would stay the same is if you added a data point exactly 5 away here, because the standard deviation is 5.
Oh.
Does that make sense? That's a great question.
I thought I was thinking like it had to be like more than 5 away in either direction for it to change. You know what I mean?
Yeah, but if it's exactly 5 away, that's the average distance from the mean, so it'd stay the same.
So even if it's like less than 5, it's still going to change the standard deviation?
I'd say it decreases. Yep, good question. Any others? Okay, we need to make a dot plot of this data to help us answer the next couple of questions. So make a dot plot. This is for run scored. So I'm going to label the dot plot run scored. My minimum's 0, my maximum's 12, so just go ahead and go by ones. So if you have a highlighter, you guys, it'll make it a little quicker. The first one, you have a dot at 0, so you put a dot at 0. Next one, dot at 5, so you put a dot at 5. Remember, if it occurs more than once, stack it right on top of each other. So I have a 10, and then next I have 2 3s, so I'm stacking 2 3s. Take about 30 more seconds to finish. You guys, we've talked about finding the mean and standard deviation in your calculator, so I'm just going to go ahead and tell you those values. I guess I should have used, it was estimated. And I'm also going to put down homework hints. If you want, maybe write these in different color with your highlighter so it stands out. So we found the mean, remember, using one variable stats a bunch of times last chapter. Standard deviation, for those of you that weren't here Monday, same menu, just a couple statistics down. You go to one variable stat, same menu, just a couple statistics down, standard deviation's S. Okay, so it says, what percent of the data falls within one standard deviation of the mean? Okay, within one standard deviation of the mean. So that's gonna be my mean plus or minus one standard deviation. Okay, so let me plug in the values. My mean is 3.63 plus or minus 2.79. So I'm going to find my lower bound and my upper bound. So my lower bound is going to be 3.63 minus 2.79. My upper bound is going to be 3.63 plus 2.79. Go ahead, figure those out. Lower bound should go on the left. The smaller number on the left, higher number on the right. Great question. Hopefully you got 0.84 is your lower, 6.42 is your upper. Okay, so now go back up here. It says what percent of this data falls in this interval? Okay, so 0.84, does that include dots at 1? Are dots at 1 inside this interval? Yes. Are the dots at 0 inside this interval? No, so we're about from here to 6.42. Are the dots at 5 inside this interval? Yes. Are the dots at 6 inside this interval? Yes. Is that dot at 8? No. Okay. Remember, this is out of 30 games for the Tigers. So our sample size is 30. So what percent is within, this is our boundaries, within 1 standard deviation? How many out of 30 dots are inside here? Well, I can see there's 5 outside, so how many are inside? 25, which is about 83% of the data. Now we're going to go out 2 standard deviations. So we're going to have a wider interval, so we're probably going to collect more data. So you're going out 2 standard deviations for this one. So it's your mean plus or minus 2 standard deviations. So that's going to be, my mean again is 3.63 plus or minus 2 times the standard deviation. So your lower bound is 3.63 minus 2 times 2.79. And my upper bound is going to be 3.63 plus 2.79. Sorry, plus 2 times 2.79. So hopefully you get negative 1.95 to 9.21. So you guys, on your dot plot above, are dots at 0 in this interval? Yes. How about the dot at 8? Is it inside this interval? How about the dot at 10? No. So out of 30 dots, how many of the dots are within this interval? 28. Out of 30, which is about 93%. Questions? Okay, so this is a recap from Monday, letter E. Suppose we had 2 runs to all the data points above. So the 0s become 2s, the 1s become 3s, the 2s becomes 4s. What happens to the mean? Who remembers from Monday? It goes up, specifically by what? 2. Now, your standard deviation. You guys, the data shifts on the number line. Everything shifts up by 2. Did the data become closer together or further spread apart? Nope, so standard deviation stays the same. Now, what about the range and the IQR? Let's think about this. Your old range, well, my old max was 12. My old min was 0. So 12 minus 0, my old range was 12. If I add 2 to all the data points, what's my new max? 14, what's my new minimum? Guess what my range still is? 12. So the same thing goes for IQR. Okay, so you guys, you might want to highlight this. I'm going to write it in red pen so it stands out a little bit. So when a constant is added to every data point,
Is it the same for subtracting?
so if you want to write added or subtracted, to every data point, all measures of spread stay the same. What do I mean by measures of spread? There's 3 of them. One measure of spread. Give me one. Range. Someone different. Give me another measure of spread. IQR. And then the last one, what did we learn this chapter? Standard deviation. So the influence of outliers. Previous chapter, you guys, we talked about how outliers can drastically affect the mean and the range. We are going to add standard deviation to that list. We're going to skip over this question and just talk about the last 2. Okay, going back to the Tigers data set. Let's say I remove 12 from this data set. I take away the 12. So it's the Tigers' best offensive performance. What's going to happen to the mean? I take away their best offensive performance. I take away your highest grade in this class. Tom, what's going to happen? It's going to decrease. Okay, so their data's like this. I take away the mean, okay, so I take away the max, so it goes down. What's going to happen to the range? It's going to go down. What's going to happen to standard deviation? Down. Because the data's less spread out. Because now their data's closer together if you remove their max. Does that make sense? Their new max is lower. Go ahead, try your turn on your own. This time, for your turn, you're removing the zeros. What happens to the mean? You remove the lowest values. If I remove your lowest test score in this class, you guys, what's going to happen to your average in this class? It's going to go up.
It's a 0.
Huh?
But it's a 0.
Wow, you'd hope that no one's test score is a 0. But, yeah, zeros, your new minimum is now lower. Your new minimum is now 1. So, sorry, average. Your average, if I remove the lowest numbers, the average is going to go up, right? If I remove the lowest numbers, the average is going to go up in any data set.
Even if it's 0?
Mm-hmm. Someone cheats on a test, they get a 0, right? If the teacher drops their lowest test score, is their grade going to go up? It sure is. Okay. The range is going to do what, guys? You take away the zeros. The data goes from here to here. What's going to happen to your range? Decrease. Your data is now closer together, and your standard deviation is also going to decrease because your data is closer together.